Hello everyone, this is your tutor AB and today we're going to be solving a problem from the May 2019 IB Physics examinations. This is a HL paper 1 question worth 1 mark. Satellite X is in orbit around the Earth. An identical satellite Y is in a higher orbit. What is correct for the total energy and the kinetic energy of satellite Y compared with satellite X? Okay, so I want you to understand that kinetic energy, Ke, has the equation half mv square. But we also know that the speed at which it's orbiting this planet can be written as the root of gm over r, which is an equation given in your data booklet. So we can rewrite the same kinetic energy in terms of half m root of gm over r the whole square. So again, if you rewrite this, kinetic energy is nothing but gm m over 2r. That's your kinetic energy. Now we need to see what is the correlation between the radius and the kinetic energy, because that's what they're asking us. It's changing its orbit, it's changing its distance from the center of the planet. So let's see, a satellite Y is in a higher orbit, so it has a greater radius. So we say Y has greater radius, X has a lesser radius. So how will we put this into the equation? We don't need to substitute anything. We can just essentially test our concepts. If you have a greater value for r, since there's an inversely proportional relationship, when r increases, kinetic energy decreases. So as x has a smaller radius than y, its r is also smaller, so its kinetic energy is greater. Okay, so it's got to be either this or it's got to be that, because kinetic energy has to be greater. But we also know we need to find total energy. Now how do we get total energy? Total energy, energy total, can be said as kinetic energy plus potential energy, gravitational potential energy. So we can write this as our equation we derived earlier, gmm over 2r minus the formula for potential energy, which is gmm over r, and this is in your data booklet. Now getting a common denominator, I'm going to skip this step, but you will get the final answer as negative gmm over 2r, with the difference between this and kinetic energy being the negative sign. So now let's think of the total energy. How does it change with the radius? Well, keep in mind there's a negative sign. So when the radius increases, the overall total energy also increases, and the reason for this is because of this negative sign. It's actually becoming less negative the greater the radius goes. So in this case, the total energy of planet X has to be less than planet Y. And the reason for this is because it has a lesser radius. So the answer is B.